In this section, we are going to look at how we can forego Rust's memory safety guarantee and run code that might be unsafe. It will continue to work as regular Rust, but we won't have the guaranteed memory safety. So it just gives us a little bit more control over our program. But remember, when using unsafe code blocks, it's important to make sure you are extra careful when dealing with memory. Writing unsafe code in Rust is actually really easy to do. All we have to do is place our code inside of an unsafe block just to let the compiler know we are about to execute unsafe code. So let's just see a quick example of this. So we're going to create a mutable variable called num, and now we are going to create a raw pointer to that variable, which is not unsafe to do. We are very capable of doing that. And we can even print out the address of these variables. And let me copy and paste. R1, R2. So now we can run this and see that our address is printed out, and it points back to the num of 5. But if we try to dereference this, then it becomes an unsafe operation. And if we try to run it, we already know it's not going to run. It says dereference of raw pointer is unsafe and requires unsafe function or block. So all we have to do in order to run this is just say unsafe and then print it and then put the unsafe code block into that code block. So now if we run it, we see that we were able to successfully dereference our raw pointer and print out the value of 5. And just because you might use unsafe code in a function, it does not mean that the entire function has to be unsafe. So notice that all we did here was wrap the code that was considered unsafe in the unsafe code block. So you can simply just use unsafe blocks explicitly where appropriate. There is no need to wrap everything in an unsafe block if only 1 or 2 or however many lines is executing the unsafe code. That way you can continue to maximize the borrow checker and ownership model that Rust provides for us.